Okay, so yesterday we were talking about the fundamental theorem. Fundamental theorem is using antiderivatives to find the area under the curve. Okay, these are definite integrals because they have bounds, right? They have bounds. Like this one right here, we're looking at bounds go from 5 to 6, so it's a very small bound. It's only 1 unit, but still, it's area under the curve for this guy here. Okay, so if we can use power rule, we just go straight power rule. If we can't, then we have U substitution, which we can use, okay, which we've been working on since last week. So this guy here, you can rewrite it. Sometimes it helps to rewrite it, sometimes it doesn't. So you can rewrite this guy as 2 times 7 minus x. And then that 2, I can move to the front, right? So don't even worry about that 2. The 2 is meaningless in terms of finding antiderivative. Really what we're doing is we need to figure out a way to do this guy here, right? I mean, I could raise it to a power, right? Instead of writing like that, I can say 7 minus x to the -1 power. But the problem with things to the -1 power with antiderivatives is I add a power and divide by the new power. That's going to be 0. So let's do this as a U substitution problem. Since this part right here is the part we really have to focus on, let's make that U. So if that's U, du is -1 dx. And then if I divide by -1, I get dx equals -1 du. Okay. So I'm going to rewrite this before I even do the problem. I'm going to rewrite it. Okay, so I'm not focused on that 2. You can leave the 2 onto the right. That's fine, but if sometimes it might make you think that you need to do something that you don't, or don't worry about it. Just move it to the front. It's a coefficient. We'll multiply it later. Okay, so now what I need to do, 7 minus x is my U. So that's going to be a U down there. Okay. Another way of saying that is U to the -1 power. That helps. I still have a U to the -1 power, right? I still have U, and if I find the antiderivative, it's going to be U to the 0 power divided by 0. I can't divide by 0. So this is a relationship we've seen several times already. Either of these two guys. What is the antiderivative of 1 over x or 1 over u? Or that's where natural log comes in, right? That's where the natural log comes in. So the antiderivative is going to be the natural log times the absolute value of u. And I have to evaluate that now from 6 to 5. Okay. That relationship here, this relationship here, anytime you see this relationship, because you're going to see it quite a bit, or this here, and you have to find antiderivative, always, always, always go natural log. It's going to be the natural log. Oh, yeah, sorry. Yep, I didn't tack that on. You are right. So what that's going to do is it's going to make a negative out here, and then du. Yeah, that's important because this 2 becomes negative out there. Yep. I forgot to plug in the dx. Okay. Okay. So now we have -2 times the natural log of 6 minus put these in parentheses, -2 times the natural log of 5. Let's see. Yep. Oh, sorry. I forgot to put u back in. Thought it looked a little odd. So u is 7 minus x. So the natural log. So before I put a number in there, I got to plug it in here. So I'm plugging in 6 in here first. So when I plug 6 in there, 7 minus 6 is 1. So it's going to be a 1 here. And then when I plug in 5 in here, 7 minus 5 is 2. So this is actually going to be a 2. Okay. Simplify as far as you can. These are non-calculator questions, so you can simplify as far as you can. Some of these you can calculate, some of these you can't calculate. So this guy right here is going to be 2 times the natural log of 1. I don't need bars anymore because 1's already positive. If it was negative, then I would need to make it positive, but it's not. Minus negative, so this is going to be a plus plus. 2 times the natural log of 2 again. The natural log of 2, since 2 is positive already, I don't need to have the bars anymore. Okay. One of these you can calculate, or one of them you should know because we've seen before. And if it's not, it should be in your notes somewhere so you don't have to use a calculator to calculate it. This guy right here is an actual value, the natural log of 1. What is the natural log of 1? 0. Yeah, the natural log of 1 is 0. Okay, the natural log, so anytime you see the natural log of 1, that's always 0. Because what it's asking is, what power do I raise something to get 1 as an answer? What power do I raise something to get 1 as an answer? 0. Anything to the 0 power always equals 1. So this guy here is -2 times 0, which is just 0. Okay, then bring this guy down, plus 2 times the natural log of 2. So your answer is going to be, the natural log of 2 is not a nice pretty number like 0 or 1. The natural log of 2 is a decimal. It's like 0.8 or 0.9, something like that. Since we don't have a calculator, since this is a non-calculator question, we leave it like that. It's okay to leave it like that because it's like leaving things in terms of pi, 2 pi, 3 pi, instead of multiplying by 3.14. It's okay. All right. Okay, so now I added a question before we get to our last question because I want to do one that's similar, because even though it's the same type of problem, the directions might trip some of you up. Anytime you look at a problem, you should always look at what's similar. What do I see that I've seen before? Okay, don't worry. A lot of you focus on the differences. What's different between this one and the last one? That's okay, but you should always focus on what's the same. Because if you focus on what's the same, you might be able to do it. And this one is one of those. Okay? So find the value, just like the last question. Write your answer as a single logarithm of a single number in simplest form. Okay, so a single logarithm. So in other words, they don't want an answer like this, right? They want an answer like that, single logarithm. Well, there's a way to do that. Actually, I could change this guy. Does anyone remember how I could change this guy that I just have a single logarithm there? Yeah. Yep, this guy in here, if they have a coefficient becomes a power. Okay, so this is actually 2 squared. So if I do that, oops, not 2. It's actually 4. So these two are actually the same. Okay. It's called the power rule of logarithms. Okay. That's what they mean. So if we get a situation like that, that's how we take care of it. Okay. All right. So let me rewrite this. Okay, so the dx they just had on top. Sometimes I'll put the dx on top. It doesn't mean anything else. Okay. Again, the 4 I can move to the front. I can move the 4 to the front and just replace it with a 1. So don't let that 4 confuse you. Once I do those things, it's exactly the same problem as last time. What's going to be my u? What's my u going to equal? 8x minus 9, yep. Just like last time it was 7 minus x, this time it's 8x minus 9. Du is going to be 8 dx divide by 8. Okay. Start replacing things. 4, 9, 2, 1 over u, because 8x minus 9 is my u. Now I'm going to replace my dx, which is 1/8 du. Okay, the 1/8 is just a multiplier. So I'm going to multiply it with this guy that's already in front. So when I multiply 1/8 times 4, I get 1/2. So now, look at this right here. It's the same problem. It's the same exact problem, just different bounds. Well, the bounds are the easy part, because beyond bounds, you just plug in and, it's not that hard. That's not the hard part. The hard part, I think, of this problem, of these things, is finding the antiderivative. Well, it's the same antiderivative. It's going to be 1/2. Oops, don't need that anymore. You're going to have natural log of u from 9 to 2. Okay. Plug u back in. Okay, so I'm going to do that down here. So u was 8x plus 9. Okay. So first thing I got to do is plug in 9. Was it plus 9 or was it minus 9? Minus 9. There we go. Okay. Plug in 9 first. Plug in 9 for x. So if I plug in 9 here, I get 72. 9 times 8, 72. Minus 9 is 63. So I get 1/2 the natural log of 63. I don't need bars anymore since 63 is already positive. Okay. Plug in 2 here. 2 times 8 is 16. 16 minus 9 is, that's 7? Yep. Okay. Okay, so natural log of 63 and the natural log of 7. Those are numbers that I can't calculate in my head. Those are numbers that are calculator numbers. Well, we can't use the calculator question or calculator on this question. And on top of that, we have to write our answer as a single logarithm. So kind of like this. Our answer has to look like that. Natural log of one thing. So we're going to have to use some properties like we did last time. One of them is the power property, the one we used last time. What's the coefficient for each? For each, what's the coefficient? For this guy and this guy, what they have the same coefficient. What is that coefficient? Besides natural log, what do they share in common? That's the coefficient in front, right? Last time we moved it as a power. We're going to do the same thing here. Okay, so it's going to be to the 1/2 power. So we have natural log 63 to the 1/2 power minus natural log 7 to the 1/2 power. One-half power means square root. 63 and 7 don't have nice, pretty square roots. Okay, so I don't want to take square root right now. Now, how do I combine these two guys here? I'll give you a hint. It has something to do with that minus sign there. There's a way I can combine them. There you go, use division. Yep, use division. It's another property. It's called the quotient property of natural logs. It's covered in Math 3. If you look in your Math 3 notebook, it's covered in there. You can combine, since they have the same natural log, since they're both natural logs, and they have a minus in front, I can combine these two guys by division. So it's going to be 63 to the 1/2 power over 7 to the 1/2 power. If they have the same base, or sorry, if they have the same power, I can move the power to the outside, right? I can move the power to the outside, so I can further simplify it. 63 over 7 to the 1/2 power. And I can do one more thing, actually two more things. 63, 7 goes into 63 9 times. What is 9 to the 1/2 power? 3. There we go. That's what I want. Single logarithm, no powers, no division, no nothing. Okay? All right. Okay, last one we're going to do in the notes, then I'll give you some time to work on your assignment. We've done some E stuff, but I wanted to include a couple examples here just so that for practice. Okay, so it's two terms. 8e to the negative 0.2x minus 8. Okay? Give it a shot. Try this one. I'll give you a hint. Split them up. Split them up first. I'll do the first step for you. Okay. So I did one side of it because that part you've seen before. Well, you've seen these types of stuff before, but that part was nothing new. That was from weeks ago before the quiz. You had a problem like that on the quiz. The function is 8, right? So horizontal line at 8, 5 wide. You could probably do that in your head now. 8 by 5 is 40. That's 40 right there. Okay. This part over here, though, we can't do that, right? So, but what can we do? What have we learned thus far that we can use to solve this part over here? What can we use? What can we do with the exponent? You're right. What do we do with the exponent? That's where we're going to start off. What do we do with the exponent? That's u. Yep. Make that u. Because e to the x power or e to the u power, I can do that. But I can't do 8. I can't do e to the negative anything else power, right? So the 8 we're going to move to the front. So let me do this. We're going to make u the power. Remember, sometimes that's where they're hiding. Du okay, divide by the power, or divide by the decimal, and I get dx equals 1 over negative 0.2 dx. All right. So now let me plug some stuff in. So 8 is going to go in the front. And it's going to be e to the u power. And then instead of dx, I need to plug in that guy. Okay. 1 over negative 0.2 is just, it's a whole number. It's, well, it's going to move to the front. I think it's negative 5. Okay, 1 over negative 0.2 is, if you actually calculate that, the answer is negative 5. So it's going to move to the front with the 8. Okay, so 8 divided by negative 0.2. So instead of dividing by negative 0.2, what you're really doing is multiplying times 5. Okay. So it's going to be negative 40. That becomes negative 40. Because negative 0.2 is the same thing as negative 1/5. E to the u stays e to the u. And I have to evaluate that from 0 to 5. Okay. So I got to put u back in. Okay. Now what I'm going to do is I'm going to plug in negative 40 times e to the negative 0.2 times 5 minus negative 40 times e to the negative 0.2 times 0. Okay. Simplify. Well, if I simplify the powers, they become nice, pretty numbers. Negative 40e 5 times 0.2. Negative 0.2 is negative 1. Uh, 0 times anything is just 0. Anything to the 0 power is just 1. So in here, that's just 1. So you're just going to get positive 40 there. Here, you can change this to negative 40 over e, because e to the negative 1 just means e on the bottom, plus 40. And then we had the original, which was minus 40. So this part right here, I got to bring down. Not the original, but the part that I did at the beginning. minus 40. Forties cancel out, and you're left with a negative 40 over e. Okay. Anytime you're doing an e problem, you're having to do antiderivative of an e problem, and the power is anything other than x. U substitution with that power. U substitution with that power. That's where to start. So anytime you have an e problem and the power is anything other than x, that's going to be your u. Start with there. That's just something you're going to see. Okay. All right. So we got about 24 minutes. I want to give you guys some time for you guys to practice on your own. So grab your desk number Chromebook, and you guys can get started on yours. I'll make sure